Hello everyone and welcome to my channel. Today we are going to unravel the mystery of LeetCode problem number 20, valid parentheses. By the end of this tutorial, you will not only have a rock-solid understanding of how to solve this problem, but also gain valuable insights into algorithmic thinking. All right, let's dive into the problem itself. We are given a string containing only parentheses, a left parenthesis, right parenthesis, left brace, right brace, left bracket, right bracket. So our task is to determine whether this string is valid according to three rules. Number one, open brackets must be closed by the same type of brackets. Number two, open brackets must be closed in the correct order. And the third rule is every closing bracket has a corresponding open bracket of the same type. Well, the key idea here is to use a stack to keep track of the open brackets as we encounter them. When we encounter a closing bracket, we check if it matches the most recent open bracket on the stack using the base dictionary. This approach ensures that open brackets are closed in the correct order and that every closing bracket has a corresponding open bracket of the same type. In essence, the stack acts as a tool for maintaining the correct order of brackets and ensures that they are closed properly. If at the end the stack is empty, the string is valid, and otherwise it's not. So let's break down each line of code. Here we define a class named solution. This class typically contains methods to solve specific problems in LeetCode. In this case, we have a method isValid that checks if a given string of parentheses is valid. And this line defines the isValid method within the solution class. It takes two parameters, self, which is a reference to the instance of the class, and s, a string, which is a string containing parentheses. It also specifies that the method returns a boolean. Here we create a dictionary named base. This dictionary maps closing brackets to their corresponding opening brackets. The syntax here is a tuple of strings representing valid pairs of brackets. The dictionary will help us quickly check if a closing bracket matches the most recent open bracket. And we initialize an empty list named stack. This list will serve as a stack to keep track of open brackets as we process the string. This line starts a for loop that iterates through each character IDX in the input string s. And we check if the current character IDX is an open bracket here. And if it is, we execute the code block below. And if the current character is an open bracket, so we append it to the result list, to the stack list. And this simulates pushing the open bracket onto the stack. If the current character is not an open bracket, in other words, it's a closing bracket, we enter this elif block. We first check if the result stack is empty. In other words, there's no corresponding open bracket. If it is, or if the current character doesn't match the expected open bracket based on the base dictionary, we return false, indicating that the string is not valid. The result The stack pop function removes and returns the most recent open bracket from the stack for comparison. After processing all characters in the string, we check if the result stack, if the stack is empty. If it is, we return true, indicating that all open brackets have been correctly matched and closed. If there are unmatched open brackets left on the stack, we return false. In summary, the algorithm employs a stack, which is a stack to keep track of open brackets. It iterates through the string, pushing open brackets onto the stack and checking closing brackets against the most recent open bracket on the stack. If a mismatch is found, or if there's no corresponding open bracket for a closing bracket, the algorithm returns false. If the stack is empty at the end, it means all brackets have been matched and the algorithm returns true. The time complexity of this solution is big O of n, where n is the length of the input string s. This is because we iterate through each character in the string exactly once, and the time complexity is linear, right? And the space complexity is also linear and depends on the length of the input string s. In the worst case, if all characters in S are open brackets, the stack could potentially contain all n characters. Hence, the space complexity is also a big O of n. It's important to note that both the time and the space complexities are linear, making this solution highly efficient for checking the validity of parentheses in a string. The use of the stack allows us to keep track of open brackets in the correct order and efficiently match them with closing brackets while ensuring that the algorithm runs in linear time. And there you have it, folks. We have successfully tackled the valid parentheses problem in Python. I encourage you to practice this algorithm and explore more LeetCode challenges to strengthen your coding skills. I hope you found this tutorial helpful. If you did, please like and subscribe for more Python programming tutorials. If you have any questions or suggestions, please leave them in the comments below. Happy coding and thanks for watching. Goodbye!